Here we have a boat tied to a pier. On that pier is a winch that's pulling the boat in. So I define the horizontal distance as x, I define the distance from the vertical distance as y, and I define the length of the rope from the boat to the winch as w. In other words, the hypotenuse of that right triangle. We know that the winch is being pulled in at a rate of -4 feet per second, and you'll notice that that is a negative sign because the value of w, as time goes on, is getting smaller. And again, anytime the value gets smaller, the rate of change would be a negative value. We're looking for the speed at which the boat is being pulled in when the winch is, or when the rope, I should say, is 13 feet. So in other words, how fast is the boat going in the water? Looking at the picture, it should be fairly obvious that this is a Pythagorean theorem problem. So we get x squared plus 12 squared is equal to w squared. And again, you'll notice I plugged the 12 in right away. Why did I plug the 12 in right away, even after I defined it as a variable? That 12 never changes. The winch doesn't move up and down on the pier. It's attached to the pier and is fixed, so it stays there the whole time. Taking the derivative here, we get 2x dx dt. By now, this should be pretty commonplace. 2w dw dt. 4 unknowns in this problem. What do I know? Well, again, I'm going to have to do a sidebar over here and figure out one of the variables because I know what x is. I don't know what x is. I know what w is. It's 13. I'm looking for dx dt. I know what dw dt is, but I need to find x. And so I come back here to the original problem and I say x squared plus 12 squared is equal to 13 squared at that snapshot in time. And therefore, using your vast stores of geometric knowledge, you recognize this to be a nice little Pythagorean theorem problem again. So x is equal to 5. Therefore, we can plug and chug. Let's see, this would be 2 times 5 times dx dt, which is what we're looking for, is equal to 2 times 13 times -4. Which is 10 dx dt is equal to 8 times 13 is -92, I believe, which gives me dx dt being equal to -10.4. And again, units, x is measured in feet, t was measured in seconds, so we've got a value of -10.4 feet per second. Again, I like the negative number because the value of x is getting smaller as time goes on.